A box is given a push so that it slides across the floor. How far will it go given that the coefficient of sliding friction is 0.2 and the push gives an initial speed of 4 meters per second? And when I say sliding friction, there's a different coefficient for a box that's moving than there is for one that's just sitting there. It's a little harder to get it going than it is to keep it going. So you have a smaller coefficient of sliding friction, but don't let that part bother you. It's just detail for the problem. All right, so let me just list the stuff that we were given. So the coefficient of friction is 0.2. The initial velocity that it starts moving with is 4. And we want to know how far it goes, which in physics we just write as delta x. All right, but we're missing something here. If it starts out at a speed of 4 and then it eventually comes to a stop, well, we need to know how much time it takes to come to a stop. And in order to do that, we've got to access acceleration. You ever notice how acceleration is kind of the gap between the motion of the object and the forces acting on it? That's because of Newton's second law. With the F net equals ma, A is kind of the bridge between the motion of the object and the net force that's acting on it. So we got to find A here first if we want to do anything. All right? And in order to find A, we've got to find the net force. So I'm just going to start out with a force diagram here so we can see what the heck's going on. So they told you, well, actually they didn't tell you the mass of the box, did they? No problem, I'll still work it out. So we've got a downward force caused by gravity, which is equal to, I'm just going to use 10 times m. And you also know that there's an upward normal force of 10 times m. All right? And there's also going to be a force of friction. So I'm assuming the box is moving to the left. So I'm going to write force of friction over here. And you guys learned before, the force of friction is mu times the normal force. So it's just going to be 0.2, I'll just write it over here. FF equals 0.2 times, well, we know what normal force is, it's 10m. So 0.2 times 10m is actually going to be, force of friction is 2m, right? So we write it like that. And then if we want to figure out how far the thing actually went, now that we know force of friction, that's where the net force is coming from. It's from the friction that's pulling it back. These two just cancel, right? So if the net force equals 2m, and we know that, ever notice how we use this on pretty much every single problem? If you're ever stuck, this might be a good step to use. It might be the thing that you're forgetting to do. If we know F net equals ma, and we know that the net force is 2m, then 2m equals ma, and imagine that. We didn't need to know the mass of the box. All right, so A equals 2. Or you could also think of it as a negative 2 because it's in the backwards direction. Right, this force was sort of like negative 2m. So just keep that in mind, that it's in the backwards direction. All right, now we can find delta x because we finally have A. So I like this formula. All right, final velocity is going to be 0 because it comes to a stop. So we get minus initial velocity squared, so that's the opposite of 4 squared, equals 2 times minus 2 times delta x. And we're looking for this. So minus 16. Remember, this minus belongs to all that junk, so don't let the square thing take away your minus sign. Equals minus 4 delta x. Math is easy from here. The box slides 4 meters before coming to a stop.